Let's take a problem based on beam. Problem based on beam, and our interest is find out reactions at support of given beam. So in the problem, a simply supported beam is given, that is AB. AB is simply supported beam where at A and B we are having two simple support, and it is subjected to a uniformly distributed load to a length of 2 meter, and the intensity of this load is 500 Newton per meter, and we are having 2 point loads. The value of these 2 point loads are 500 Newton and 1000 Newton, and this distance is 2 meter, and this distance is also 2 meter. So let's take this point is C and this point is D. And now we are interested in reactions at A and B. So before starting this problem for finding out reaction, first of all identify the supports. So support at A and B, if we look the diagram, these are the simple support, and according to our theory, simple support is having only one reaction. So for this problem, there will be one reaction in vertical direction. So we can say that it is Ra at A and Rb at B. So now our interest is find Ra and Rb. So if we look this system, the beam is carrying a uniformly distributed load as well as point load, and it is in equilibrium, so we can apply the conditions of equilibrium. So first condition of equilibrium, that is algebraic summation of all horizontal forces should be zero. Horizontal means all the forces in x direction should be zero. So according to our sign convention, positive x is positive, negative x is negative, positive y is positive, and negative y is negative. So according to our sign convention, if we apply the condition number 1, algebraic summation of all the forces about x-axis or horizontal will be 0. So at A there is no horizontal forces, at C, D and B there is no horizontal forces. So all the horizontal there is no horizontal forces, so there is no need of applying the first equation. Second equation, algebraic summation of all the vertical forces should be 0. So in vertical direction we are having Ra, that is in positive direction, so plus Ra. Rb in positive direction means positive y direction, 500 Newton point load, that is in downward, so minus 1000 point load, that is in downward 1000, and there is a uniformly distributed load of intensity 500 Newton meter. We have to multiply it with the span where it is distributed. It is the span of this 2 meter, so that is 2, and it is acting in downward direction, so negative plus to 0. So Ra plus Rb, from this equation we are having 1000 plus 500 plus 500 into 2. So Ra plus Rb, we are having 2500. So Ra and Rb, we are having 2500. So we are having two unknowns. So one more equation we want. So we can use the condition number 3. Algebraic summation of moments of all the force about A should be 0. And if we talk about this Ra, if we talk about Ra, so due to Ra, moment at A will be 0 because perpendicular distance is 0. So Ra into 0. If we talk about this 500 Newton load, so 500 and perpendicular distance is 2 meter, so the moment will be 500 into 2, and we are dealing with the vector quantity, so our sign convention. Clockwise movement is positive, anti-clockwise movement is negative. So due to this 500, movement will be in clockwise direction. So it will be 500 into 2 clockwise, so positive. Similarly, for this 1000 Newton point load, distance is 2 plus 2, that is 4. So 1000 into 4, and again in clockwise direction, so positive. Similarly, for this uniformly distributed load, we have a total loading of 500 into 2, and it will act at the center of gravity, means which is acting here. The distance from C for this CG will be 1 meter. So total distance from A 1 plus this 2, that is 3. So it will be 3, and again the movement is in clockwise direction, so positive equals to 0. And one more movement we have to see, that is due to RB into 2 plus 2 plus 2, that is 6. So we can take this RB into 6, that is in clockwise direction, and now we have to equate it with 0. So now again I am writing this equation, that is 500 into 2 plus 1000 into 4 plus 500 into 2 into 3. These are clockwise movement, and this anti-clockwise movement due to this RB into 6 plus to 0. So now that is 1000, that is 4000, that is 3000, and equals to 6 RB. So 7000 divided by 6 equals to RB. So RB will be 1166.67 Newton. So by this way we can find out the value of RB, and we know RA plus RB equals to 2500. So RA will be 2500 minus RB. So 2500 minus 1166.67 equals to 1333.33 Newton. So by this way we can easily find out the reaction at the surface. Let's take another problem. Here we are having an inclined plane which is making an angle 30 degree with the horizontal, and we are having the cylinder which is resting on this plane, and we are having an obstacle of height 10 centimeter, and the radius of this cylinder is given, that is 30 centimeter, and weight of the cylinder is also given, that is 100 Newton. Now we are applying the force P parallel to the plane, that is P, and now we have to find out value of P when cylinder just start motion over the block. So we are interested in the value of P such that this cylinder will be just start motion over this obstacle. So now just start motion, it means it is in limiting case, means it is in limiting equilibrium. So we can apply the condition of equilibrium for solving this problem. So first draw the free body diagram for this thing. So if we draw the free body diagram for this case, we are having three forces. So let's draw the free body diagram of cylinder. So we have to isolate this cylinder from other surface. One is the weight which is acting in the downward direction. Second, that is the reaction at the obstacle. It's coming like that. And third one, that is the force P, which is parallel to the plane. And this one is suppose, if we see here, this obstacle is suppose point is A. So here we can also note this point is A. So now we are having the three forces, the reaction, the force P and 100. And now we have to find out the value P. So first of all, we are interested in this distance. Suppose if we talk about here, then if we see this one is the distance, we can say that it is a 30 centimeter. This is the radius, and this distance, if we talk about this thing here, this, and if we talk about this distance, this is again 30 centimeters this distance. And if we draw the line, this thing, this is 10, so this will be the 20 centimeter. This, if we talk about this distance, so by Pythagoras theorem, we can find out this distance will be square root of 30 square minus 20 square. So this distance will be 30 square minus 20 square. So now let's draw this diagram again. Here we are drawing the diagram again here. We are having this plane, it is 30 degree. We are having the weight, it is W. Here we are having the obstacle. Here the reaction, and this parallel force P. This distance is 10. So this distance will be around 20 centimeters, because this one is the 30, and we know this distance is square root of 30 square minus 20 square. So now we have a better picture of the distance. So that is suppose point A. So point A, this P, the line of action of this P is 20 centimeter. And from this W, we are having two components. This angle is 30 degree. This angle is 30 degree. So we are having two components, one in that direction and one in that direction, that is W cos 30, and this one is W sin 30 degree. So now we can easily see that what are the different forces are coming here. So let's again draw the force diagram. So by force diagram, we are having one force P. Here we are having the force, that is W cos 30. We are having the force is W sin 30, and we are having one more force, that is called reaction R, and that is the point A. So now we are interested in point the force P. So if we see the distance between A and P, perpendicular distance, we can easily see that is 20 centimeter, and this distance we can easily say it is square root of 30 square minus 20 square. So let's take, and condition number 3, algebraic summation of moments of all the force about A should be 0. So the R is passing through A. So due to R, moment at A will be 0. Due to this W cos 30, W cos 30, perpendicular distance is 1. It is nothing but 30 square minus 20 square. And the nature is in anti-clockwise direction, so negative. So our sign convention we know, clockwise positive, anti-clockwise negative. Similarly, due to this P, the perpendicular distance is 20, so P into 20, it is in clockwise direction, so positive. Due to this W sine 30, perpendicular distance is again same 20, but is in anti-clockwise direction, so it is negative, equals to 0. So now we are having W cos 30 into 30 square minus 20 square equals to P minus W sine 30 into 20. So I am writing again the equation W cos 30 into 30 square minus 20 square equals to P minus W sine 20 into 20. So we are having the value of W is given, that is 100 Newton. So 100 cos 30 is root 3 by 2 into this value 22.36 equals to P minus again 100 sine 30 degree. Here it is sine 30 degree, sorry. So it will be 1 by 2 into 20. So that is 1936 equals to 20p minus 1000. So P will be 936 by 20. So this value will be 46.8 meter. This is the required value. Let's take another problem. There is a two prismatic bar PQ and RS is given, that is PQ and RS is given in the problem, and P is attached with the wall with the help of this hinge support, and weight of each bar is 150 Newton. Now at S point 200 Newton load is there. Now we have to find out the value theta. So our interest is find theta. So if you see there are two prismatic bar PQ and RS which are welded together, and weight of each bar is 150 Newton, and here we are applying the load of 200 Newton. So now we have to find out, by the application of 200 Newton, it will rotate about the hinge and it will make an angle theta. And now after making the angle theta, it will be in rest. So now we have to find out the value of theta. So if you see this problem, then we can easily say that it is in equilibrium. So we can apply the conditions of equilibrium here, and we are only interested in value of theta. Means we are having only one unknown theta. So by directly one equation we can solve the problem. So before starting the problem, let's see where this load 150 will act. 150 is the weight of each bar. So it will act at the center of gravity, that is 150 Newton. Here for RS, center of gravity is there, so it will be 150 Newton. And let's take PQ equal to RS equals to 2L. So this one will be the L, this one will be the L, this one will be the L, and this one will be the L. So now we can easily apply the condition of equilibrium. So that is algebraic summation of moments of all the force above P should be 0. So the reaction at point P, the moment due to reaction at point P at P will be 0 because perpendicular distance is 0. So now we will find out moment due to 150 Newton at point P. So we are interested in this perpendicular distance. It is nothing but L sine theta. So now we are having 150 into L sine theta. So, and the nature of this movement, it is in anti-clockwise direction. So according to our sign convention, it is negative. Movement due to this 150 Newton at this point P, we have to consider this perpendicular distance. It is nothing but L sine theta, 2L sine theta. So now we are having 150 into 2L sine theta, and again it is in anti-clockwise direction, so it is negative. Due to this S, we are having movement in the clockwise direction. So due to this S, we have to consider this 200 Newton. So we have to consider 200. Now we have to consider the perpendicular distance between these two. So actually it is here, it will be somehow away from this. So if you take this thing and then we have to take this distance. So this distance, you see, this one will be the, this one, this angle is again theta. So this one will be the L sine theta, L cos theta, and this distance will be, the full distance will be 2L sine theta. This full distance is 2L sine theta. So now the total distance between these two will be L cos theta minus 2L sine theta. So that is this thing, and the moment it is in clockwise direction, so it is positive, and it should be 0. Okay, again I will draw the diagram, and I will show all the forces, all the perpendicular distance clearly, and it will be very good for you. This is our bar, and this angle is theta, and here we are having 150 Newton, here we are having again 150 Newton, and here we are having 200 Newton, and here we are having the angle theta. And now we know this distance is L, this distance is L, here this distance is L, and here this distance is L. And now we are interested in algebraic summation of moments of all the force above point P should be 0. So the reaction at P is passing through the point P. So moment due to reaction at P at point P will be 0. So we are not considering this thing. Moment due to this 150, the perpendicular distance we have to find out. It is nothing but L sine theta. So moment due to this 150, 150 into L sine theta, and it is in anti-clockwise direction. So anti-clockwise is negative and clockwise is positive. So we have to assign negative. Similarly, due to this 150 Newton, perpendicular distance will be 2L sine theta. So 150 into 2L sine theta, and again it is in anti-clockwise direction, so negative. Moment due to this 200 Newton, 200 into perpendicular distance we have to see. So this is the line of action here, this is the line of action of this force. We want this distance. So we know this is 2L sine theta here, and by this way also we can see that this one is L cos theta, and if we subtract 2L sine theta with L cos theta, we can get this distance. This is nothing but L cos theta minus 2L sin theta. So we are having L cos theta minus 2L sin theta. And it is in clockwise direction, so it is positive. It's to 0. So I believe that now it's very clear to you because I draw a big picture here, and with the help of this it is very clear to you. Now we can easily simplify this thing. L we can cancel out. So here we are having 150 sin theta plus that is 300 sin theta equals to or we can minus it 200 cos theta minus 2 sin theta equals to 0. And if we solve this thing, we are having 850 sin theta because here 150, 300 and that is 400. So 4, 5, 6, 7 and plus 700 plus 150 which is 850 equals to 200 cos theta. So tan theta will be 200 by 850. So we are having 0.23529. So theta will be tan inverse of 0.23529. So theta will be 13.24 degree. So by this way we can easily get the value of theta by applying the only one equation, that is algebraic summation of moments of all the force about any point should be 0. So if we talk about all the examples we already discussed, so whenever we required only one equation, so directly by using the moment equation we can directly find